This tutorial is a review of a technique called dimensional analysis. Technically, you all should have learned this technique in chemistry class. However, it is something that comes back in AP biology because a lot of times when we're working with experimental data, we have to perform conversions. Now, this is not the only technique to solve mathematical problems, but it is a nice organized technique, and so I'm going to give you a walkthrough, and again, this should really be a review. So these three problems are straight from the summer assignment. This is problems number 4 through 6. I already have the answers up, but I'm going to show you the setups to get from the starting point to the answers. So question 1, they give you some conversion factors, and they ask how many milligrams of carbon are fixed if you provide 3.7 milligrams of oxygen. So we are going from milligrams of oxygen, that is our starting point, and we need to get to milligrams of carbon. So if we look at our conversion factors, we are always going to start by writing the one piece of information we were given. Our starting point is going to be, in this case, 3.5 milligrams of oxygen. Now, to get from milligrams of oxygen to milligrams of carbon, I see two conversion factors. So I need a conversion factor that has milligrams of oxygen in it so that I can cancel that unit and change it. And so I see my first conversion factor here. So 1 milligram of oxygen is equal to 0.698 milliliters of oxygen. So I can put this into a fraction. Now the fraction can go two different ways. 0.698 milliliters of oxygen over 1 milligram of oxygen, because that would basically be equal, those two values are equal to each other. Or I could put 1 milligram of oxygen on top and 0.698 milliliters of oxygen on the bottom. Now, to choose which one of these I want to pick the one that's going to cancel milligrams of oxygen. Since milligrams of oxygen is basically my numerator in my original number, I want it to be my denominator in my conversion factor. So 1 milligram of oxygen is going to go on the bottom, and 0.698 milliliters of oxygen is going to go on the top. If I work this out, which I'm not going to do, but if I was to work this out right here and stop, milligrams would cancel, numerator, denominator, I would multiply, and my answer would be in milliliters of oxygen. However, I'm going to keep going, and you could do this in separate steps if you wanted to. All right, so at this point, I am in milliliters of oxygen. I still need to get to milligrams of carbon. So I see my second conversion factor here. 0.536 milligrams of carbon are fixed per milliliter of oxygen. Again, I want to cancel milliliters of oxygen. So my 1 milliliter of oxygen is going to go on the bottom, and my 0.536 milligrams of carbon is going to go on the top. Again, I could flip this if I wanted to cancel milligrams of carbon instead, for example. Now, double checking my work, I see that milliliters of oxygen will cancel, and my answer will be in milligrams of carbon. And I will work my way across and do 3.7 times 0.698 times 0.536, and I will get my answer of 1.4 milligrams of carbon. You might get an answer that goes to 100th place. I rounded. And on the AP exam, a reminder that you do not have to use significant digits. They will tell you where they want you to round. So you would just read in the question, it would say round to the nearest tenth or round to the nearest whole number, and you would just follow those instructions. So you don't need to sort through and try to figure out how many significant figures should be in your answer. Let's look at the second one. A particular organism produces 2.5 milliliters of oxygen per second. So this is my starting number. So 2.5 milliliters of oxygen per every 1 second. Notice this time we're actually starting with a fraction, or I should say with a unit in our numerator and our denominator. So this is going to be important. So they say how many liters of oxygen, so I see that I'm going to need to convert to liters of oxygen, will be produced in 12 hours. So I need to convert my time to hours. Now I can convert milliliters to liters first, or I can convert my time first. It really doesn't matter. I'm going to start by converting milliliters to liters. Here's my conversion factor. 1,000 milliliters is 1 liter. Notice milliliters is in my numerator here, so I want milliliters in my denominator here. And we see that here, milliliters of oxygen will cancel. And now if I was to stop here, if I multiplied this, or divided actually, and stopped, my answer would be in liters per second instead of milliliters per second. But I'm going to keep going. Now I'm going to convert my seconds to hours. So I have two conversion factors. Now notice seconds is in my denominator in this problem. So in order to cancel it, I need it in my numerator here. And my conversion factor is that 60 seconds are in 1 minute. Notice seconds would cancel, and if I was to stop here, my units would be liters of oxygen per minute. I'm going to keep going. I need to convert from minutes to hours. So there are 60 minutes in 1 hour. Notice minutes will now cancel, and my units, if I stop here, would be in liters of oxygen per hour. Now, if I multiply all of this out, I'm going to get, I believe I get 9 liters of oxygen per 1 hour. But I need to go back to my question. Did they ask how many liters of oxygen would be made per hour? No. What they asked was how many would be made in a total of 12 hours. So I need to do one more step here. I need to take my 9 liters of oxygen, so 9 liters of oxygen per hour, times a total of 12 hours, and this is where we get the 108 liters of oxygen. Notice my hours will cancel, and I'll get my total. The last question is very similar to this one. So I have my conversion factors. An organism produces 1.55 grams of biomass per square foot. How many kilograms of biomass will it contain in an area that is 2,500 square meters? So my first step is I need to convert grams per square foot into kilograms per square meter. So that's my first step. So start with our given number, 1.55 grams per every square foot. My first conversion factor, I'm going to go ahead and convert from grams to kilograms. So there are 1,000 grams in 1 kilogram. Notice grams will cancel. If I stop here, my answer would be in kilograms per square foot. But I want per square meter, and I do have a conversion for that. So there are 10.8 square feet per every 1 square meter. Notice that feet are in my denominator in my original number, so I want them in my numerator here. And now, if I multiply across 1.55 divided by 1,000 times 10.8, I get 0.01674. Remember, my units at this point are kilograms per square meter. But, notice the question, they want to know how many kilograms would it be in a total of 2,500 square meters. So I take my 0.017 kilograms per every 1 square meter times 2,500 square meters. My square meters will cancel, and this is where we get the 41.9 kilograms. And again, you might have gotten a different answer rounding-wise, but they would tell you on the AP exam where to round.